Smelly cat, what are they feeding you? Smelly cat, it's not your fault. Well, if you know what TV show that it's from, next time you see me, I'll be the first to tell me, and I'll give you a piece of candy. But anyway, we're going to move on with section 10.2, which is continuing our study of area. We're going to focus on 3 different polygons today. And those 3 are trapezoids, rhombuses, and kites. So the goal or the objective is to find area of those 3 things, of trapezoids, rhombuses, and kites. So let's just start off a little bit about trapezoids. So just so you know, the height, this is what's going in there, the height of a trapezoid is the perpendicular distance between the bases. So we know the bases of a trapezoid are the 2 perpendicular lines, and the height is just what's perpendicular to those. So we have it labeled here. The height would be like that. All right. If it's rotated, you got to rotate it so that you know that's the height. And the area of a trapezoid, as seen in Theorem 10.4, is half the product of the height and the sum of the bases. So you add up the bases, multiply that by the height, times 1/2. Okay, that's the formula right there. So let's use that formula. Let's take a look at a couple of trapezoids. So looking at this one on the left, the height we know is 12. Base 1, it doesn't really matter. We usually do the smaller base as base 1. Base 2 would be 21. So to find the area, we use the formula 1/2. What did we say up there? 1/2 times the height, which is 12, times 2 bases added together, which is 15 plus 21, which would be equal to, I'll just do 1/2 times 12 right away is 6, times 36, and that's equal to, well, 36 times 6, 18, 216. I hope I did my math right. 216 meters squared. We talked about this. Make sure you have labels. It's square units. Alright, looking at B, you'd have to rotate this because the parallel lines are 3 and 8. Those are the bases. So the height would have to be 5, the perpendicular line to those. So same thing, area, we'll use that formula 1/2 times the height times the sum of the bases, which I'm going to do right away is 11. So you know that was 3 plus 8. Alright, which would be equal to 1/2 times 55, which would be equal to 27.5 meters squared. Alright, so that's how you use the formula for area of a trapezoid. Now, we can use it in a different way. It says find the length of the missing base. So the area of the trapezoid is 50. So let's use that formula again. Area equals 1/2 height times base 1 plus base 2. And we're given some information here. We're given the area of the trapezoid, which is 50. Plug that in there. And we're 1/2. The height is 5. And one of the bases is 14. What is the length of the other base? We're going to say the other base is just x plus 14. So we're just going to use some algebra now and solve. So it's up to you how you want to do this. There's lots of different ways you can go about solving this. One way or another, you're going to have to, I'm going to multiply by 2 on both sides to get rid of this. Multiply by 2 and multiply by 2 over here. So I have 100 equals, and then I'm going to, in the same step, kind of, I'm going to distribute 5x plus 14 times 5, 20, so 70. Should have known that. Plus 70. Alright? And then simply solve for x. Minus 70 from both sides. 30 equals 5x. Divide both sides by 5. Hopefully you get x is equal to 6. So that's the missing base. The missing base is 6. Alright? So just using that formula. Alright, let's do something else. Let's apply it a little bit differently. So find the area of each trapezoid. We are given some information about this, but not enough to use the formula. Remember, the formula is 1/2. Ooh, that was a really bad 2. times the height times the two bases, or the sum of the two bases. Base 1 plus base 2. So we have base 1 and base 2. We do not have the height. But what do we have? Well, we have that is a, if we draw this, and this is the height, we have that this is a 30, 60, 90 triangle, because there's 60 degrees here, and this has to be a right triangle. So let's see here. Can we figure out the height? Well, we know this would be 2 if this part's 5. 30, 60, 90 triangle. The height is the square root of 3 times the smaller leg. So the height is 2 square roots of 3. Interesting. Well, let's put that in there. Area is equal to 1/2 times 2 square roots of 3 times 5 plus 7, which is 12. Alright, let's simplify this. 1/2 times 2, well, those cancel each other out. Square root of 3 times 12. So the area is 12 square roots of 3 meters squared. If you'd like to simplify that and round the decimal, that's not going to be the most accurate, but it'll give you a better sense of what the actual area is. Let's see if we can figure out this other one. Actually, try this one on your own. Why not? Alright, letter B. Alright, so what I did was I figured out the missing part of the base. The bottom base there is 6, because of a 30-60-90 triangle, the smaller leg is half of the hypotenuse. And then the larger leg is that smaller leg times square root of 3, so that's how I labeled those. The top is 30, so the bottom is 36. Plug it in for the formula. I did 1/2 times 6 square roots of 3 times 30 plus 36. When I simplified it all, I ended up getting 198 square roots of 3 inches squared. Alright, last one with trapezoids here. It says find the area of the trapezoid ABC with those vertices. I already plotted it for you, and you can kind of hopefully visualize the trapezoid. I'm going to leave that one up to you to start figuring out. We'll most likely go through that one in class, but I'd like you to try to figure out what you'd have to use to figure out some of the missing pieces, because we got to figure out the bases and we got to figure out the height. Alright? So, moving on then to rhombuses or kites. So theorem 10.5, worth noting, says the area of the rhombus or kite, works the same one, is half the product of the length of its diagonals. Now remember, the diagonals of kites and rhombuses are perpendicular. So if you know the lengths of those two, multiply them together, and then multiply that by 1/2, and you've got the area of those things. So let's use that formula, this wonderful formula here. Alright, now remember, you gotta have the whole diagonal. So this whole diagonal would be, so the area for the whole diagonal would have 1/2. That one would be 3 plus 9, which is 12. And the vertical one is also 12. So 12 times 12 is 144, and you multiply that by 1/2. I think you get 72 feet squared. It's always good to have a calculator to check. Alright, number B, why don't you try on your own? Alright, again, with this one you had to use a little bit of what you learned before, so I think you could just use the Pythagorean theorem, or if you knew that 5, 12, 13 is a Pythagorean theorem, or a Pythagorean triple, then those two bases of those triangles are 5, so meaning that this diagonal right here would be a total of 10 across the 5 and 5. Plug those in, and you get the area of 80 inches squared. Alright, moving on, we got a couple additional problems here. Well, let's figure out number letter C first. It says the area of a kite is 112. We'll just rewrite this here. Diagonal 1 times diagonal 2. Alright, so we have 112. One diagonal 16. What's the length of the other diagonal? So we'll say that's x. So we just got to solve for x. So we'll bring this up over here. Using that formula is great, because we can just, well, 1/2 times 16 is 8. Divide both sides by 8. We're going to have what x is already. X is equal to, what's 112 divided by 8? I don't have that one memorized. So let's plug in. Let's do some long division. 8, 3, 2, that's going to be 4, that's going to be 32. Alright, it's 14. 14 what? It's a missing side, so it's 14 centimeters. It is not centimeters squared. Alright, bottom one. Probably the last one we're going to do. Finding area using right triangle. So there, we've already actually been doing that. But let's see here. A and B. We have rhombuses. Leave answers in radical form. Good. So we need to find the diagonals, and we need to find... Oh, that's all we need to find. So we have 30, 60, 90 triangle. This is a right triangle. This would also be 9 then. If it is a rhombus, all the sides are congruent. 30, 60, 90, meaning that this would have to be half of that. The smaller thing would be 4.5. And then the other one, if it's a 30, 60, 90, we've been working with those already, it would be 4.5 square roots of 3. That's not a 9, that's a 4. So, plug in for the area, you get 1/2. Okay, 4.5 times 2 would be 9. So that whole diagonal is 9. And the other whole diagonal would be 9 square roots of 3. Alright, simplify that, you get 81 square roots of 3. 1/2 of 81 would be 40.5 square roots of 3 feet squared. That's all we had to do. Figure out those diagonals. Trigonometry comes in handy. Don't forget 30, 60, 90 triangles. The hypotenuse is twice the smaller leg, and the larger leg is square root of 3 times the smaller leg. All right, let's look at letter B. Why don't you try to figure this one out on your own? Go ahead. Man, I gave you too easy of one on there. So for 45, 45, 90 triangle right there, it's an isosceles triangle. So if you know one of the legs, then you know the other leg. So all the triangles are 3 by 3 for the 2 legs. We don't even need to worry about the hypotenuse because that's not what we need to worry about for the area of a rhombus or a kite. So all of them are 3, meaning the diagonals are each 6. So area equals 1/2, 6 times 6, I believe if I was doing it correctly. Yep. And you multiply those out, you end up getting 18 meters squared for the area. Alright? So that is all for this one. Why don't you go ahead and answer the closing question, which is, what is the formula for the area of a trapezoid kite? What do the variables in those represent? And then try to do the error analysis at the end there. But that concludes section 10.2, focusing on area of trapezoids, rhombuses, and kites.